in companies like Variant and Checkpoint. And a few years ago, I started dealing with cloud security. I was the head of cloud network security for a Checkpoint, dealing with infrastructure service security, as well as containers and serverless. And about a year ago, I joined ARMO as the VP Product Management. And the reason I created this content was because during my role as a product manager, both in Checkpoint and in ARMO, I'm meeting a lot of customers. And while throughout my career, I developed security products, the security products actually are not part of your application, right? They protect your application, they protect your environment, but they're not part of it. And as such, they need some kind of a hook or an access or a token, API to be able to take data and act upon things that they see in your environment. And it's no matter if you're trying to protect your cloud environment or your network or application or whatsoever. And while I was meeting customers and I was telling them about the value, the security value that they're getting out of their products, I start hearing from customers questions like, hey, but is it eBPF? Are you using Agentless solution? And I was starting to repeat the answer that I'm going to share with you during this presentation, and I really hope that by the end of the presentation we will understand how you can attach a security solution to your Kubernetes environment, and what are the benefits of each option. I created some demos that I will show you throughout this session. So if we look, and I have to tell you that we, the security vendors, are not making easy life for you customers, because we also use this attachment point as part of our value proposition. So you can see companies like saying, hey, we have this solution, it's agentless, or hey, we have this solution, it's using eBPF. And I'm sorry if we're confusing you. And again, I'm going to try and create some order here and try to explain each one of the methods. And if I look at it, and I will try to categorize it into 3 categories. Basically, we have the agentless approach. You can see it here, where you connect to the API server or to your cloud provider API, and you are able to consume and use the API to get data and to take decisions upon this data. We have the node agent, or some people, the trend today is to talk about eBPF when it comes to Kubernetes, and basically it's this small orange thing that runs on each one of your nodes. And then you have the pod agent, which I'm going to describe. Basically, it's this orange thing that surrounds your pod. And again, we will talk about each one and what are the pros and cons of each technique. So when we talk about the agentless, basically it connects to the API server or the cloud account. It uses the available APIs, and these APIs might change between different versions. It requires credentials or tokens in order to be able to get to your system or to the API. And it can run in read-only, or it can have read-write permissions. And with that, I want to show you the first example. The first example that I'm going to show you the name is kind of contradictory because it's called the Open Policy Agent. But the fact is that if you look at Kubernetes, Kubernetes has this idea that when an API request comes to Kubernetes, to the master node or to the API server, it has two admission controllers that you can hook to. And this is exactly what you see here. The Open Policy Agent connects to these admission controllers, and basically you can define a logic and policy around the types of API requests that are coming into the system. And I'm going to show you an example in my setup. So you can see here, this is my Kubernetes cluster. It runs over GKE. So you can see here that I have a namespace called OPA. And you can see that I have one container running in this specific namespace. And I ran before this demo. I created a rule. The way that OPA works is that you create these scripts in a language called Rego. So I created this very simple script that basically looks at the object, the deployment object that someone is trying to insert into Kubernetes, and if it contains the name bad, it will give you an error message saying that I'm not allowing bad pods. And you can see that what I have here, I have an Nginx YAML file that the name of the deployment is basically bad Nginx deployment. And if I will try to apply it, you will see that I will get an error message saying this is a bad pod and it's not allowed by the policy. It takes a second. Okay, and here you can see it that the Open Policy Agent doesn't allow it. So basically, what we've seen here is we've seen that we have an agentless solution that connects to our Kubernetes cluster and basically gives us a security value because it looks at the posture of the Kubernetes cluster. And usually these agentless solutions are actually doing posture management, so they can scan containers, get data, give you risk score on your cluster. The pros for using this kind of attachment point is it's very easy to connect to your cluster. It's very easy to evaluate the security value that you're getting out of this attachment point. It is considered non-intrusive because if OPA will fail, even in my case, everything will work. My cluster will work. My business will work. Nothing bad will happen. It can be read-only, which it's a nice option. The cons are I gave OPA in my case. I gave it the keys to my kingdom, meaning that if an attacker will take the credentials that I gave my OPA, or if an attacker will take the credentials that you're giving to your posture management system for your cloud accounts, basically they can own your cloud. If you're using read-only, it's very nice, but it means that it can detect things. It will not be able to act upon things. You will not be able to prevent stuff or bad stuff from happening. And the last thing you need to consider is that it's limited to the APIs. And here I'm showing an example that Kubernetes has a built-in construct for network policy. This built-in construct supports ingress policy as well as egress policy. The only problem with it is that it doesn't have the ability to define things like FQDNs, URLs, and then you're kind of limited. So if you want to say, this is my pod and I don't want my pod to be able to access, or I do want my pod to be able to access google.com, you will not be able to do it in native Kubernetes, and you need another solution. So that was the agentless attachment point. The second attachment point is the host agent. And the idea with the host agent is usually you have one agent that runs per host. It can be a kernel driver. It can be a container or a pod that is running on each one of your worker nodes, meaning a daemon set. It can be a process, just a process that is running on the host. And it can be a daemon set, meaning that Kubernetes will run it on each one of the worker nodes, or it can be a singleton, meaning that you run one per cluster. And the recent buzzword is eBPF. Basically, eBPF stands for Enhanced Berkeley Packet Filtering Library. And the idea with eBPF that it's very much equivalent to a kernel driver without the challenges or the problems that we had with kernel drivers. So I think that 15 years ago, I was a developer at Checkpoint, and I used to develop kernel drivers. And back then, we used kernel drivers because it was the fastest way to process packets. If you wanted to have a good, excellent performance in software, in Linux, the only option was to run a kernel driver. But the only problem, and it's quite big, was that if you had a bug in your code, it would crash the entire host. And you would get what we call kernel panic, which is kind of bad. If you think about running a Kubernetes production cluster, and then suddenly it crashes because you have a bug in your kernel driver. So eBPF kind of tried to solve this problem. The idea is that you have a BPF program that is compiled to a bytecode, which is being validated before it's being loaded to memory. And then when it is loaded into the kernel, it is loaded in a sandbox in a way that if something bad happens in your code in the software, it will not interrupt the entire kernel. It will just interrupt the software that you created. Again, this is the promise, and I'm not trying to be an eBPF expert, but this is the way that it should work. And again, with this option, I'm going to show you an example. So I'm using Falco. Falco is a CNCF graduated project by a company called Sysdig. Basically, it's an eBPF runtime security for Kubernetes. So I'm going to show you how it looks in my environment. So here you can see that on my default namespace, I have a daemon set that in my cluster, I have 4 nodes. And you can see that on each node, I have a Falco instance that is running. And basically, it should look at my machine and create detection rules on bad activities that it is seeing. And the only thing which bothers me is if we look at the daemon set definition of Falco, I created it before, you can see some things which I will talk about later. You can see, for example, that Falco is running as a privileged container. Now we all know that running a privileged container in a cluster, it's a bad practice because it creates an attack surface and it increases the risk. If someone attacks Falco, since it's an open source project, probably everyone can see the code and then try to attack this code. And if you're entering a Falco, you basically land and own the entire cluster, right? Because it's a privileged container, and you can see that it also mounts a lot of resources from the underlying host, which is kind of bad. So that is Falco, and I will come back to Falco toward the end of the presentation. It is usually used for visibility, network security, and host protection because it sits in the kernel and it's able to see most of the things that are going in the worker nodes. Usually it's one agent per worker node, so it's kind of easy to deploy. It has good performance, relatively good performance, because it's running in the kernel level. It is capable to do almost anything that you can code, and is available to you from the operating system. For example, if I'm trying to do my Google prevention and my Google network security restriction on a specific pod, it's quite easy to do that when you're running a host agent. The cons are it's privileged. So it's like you're trying to protect your environment by using something which is less secure. Still, bugs might kill the entire node or make the entire node useless. There is the dialogue that I have and had with customers during the past years is always surrounding with the notion of end-to-end encryption. What happens if the application is encrypting and decrypting data itself using a TLS 1.3, for example? Then the host agent or the host agent is kind of blind to the network traffic itself. It just sees that it's going to your application, but you cannot do things like WAF. You cannot do deep inspection, etc. And the last thing, which I think is the biggest problem with this approach, is with the container as a service offerings like Fargate, ECS, and ACI, where basically it's the serverless notion where you give the cloud provider your container, it runs it, you don't know where it is running, and you don't have access, although you own the solution, you don't have access to the underlying host. And that is very, very challenging when it comes to a host agent. The last option, actually I'm going to split it into two parts, but the last option is a workload agent. And I call it workload agent because this agent is basically running in the same level as your workload. Basically, it's one agent that runs inside your pod, and the promise of this approach is that you don't need to rewrite your code. You don't need to compile with it. So it's not. I'm not talking about Rust or other solutions where you need to change your code. You need to integrate with an API. I'm talking about solutions like, for example, Istio. Istio is deployed using a Sidecar container. So basically, you created your microservices. You're just adding Istio as a Sidecar container to your deployment. And then basically, when pod A tries to contact pod B, then it uses the Sidecar to communicate, and you have other benefits like mutual TLS, and it gives identity to service A and service B, and make sure that when A talks to B, it is indeed coming from pod A to pod B. The other approach, and this is the approach that I'm going to demonstrate, is the agent inside your container. And the idea is that you're adding a small library to your container that basically gives you a security value without the need to change your code. It gets full observability into what the container is doing, and it has full context into the things that the container is doing. And basically, we at ARMO, for runtime protection, we chose this approach over the other approaches. And I have many things to say about it, but I'm going to show it to you, and I think it is better this way. So basically, if you're using ARMO in runtime for runtime security, and we're using other attachment options, for example, the Agentless, to do things like posture management as well. But for runtime, we chose this attachment point, and the idea is that we're attaching ourselves to the container. We're signing each one of your containers in memory, and that gives us the option to do memory protection and exploit prevention, making sure that no one changes the code of the running container. By identifying how a memory of a container looks like, we make sure that when container A talks to container B, it is done over mutual TLS, and that A is indeed allowed and is not compromised, or no one changed A to talk to B. So we know that A should talk to B, and A is allowed to talk to B. And then we see all the I/O activities, and we give the user the ability to decide if he wants to encrypt traffic, encrypt data, and save the data in an encrypted format. And that way, he gets a full zero trust environment where data is secured in transit, at rest, and in use. And in order to do that, you don't need to be an expert. I'm going to show you how it is done. So basically, the only thing you need to do is just run this SH. So you see here, I have our command line interface. It's called CACLI, and I'm giving it a command to attach and sign my GKE cluster on the Hipster demo, which I will show in my next few seconds, a few minutes during the last demo that I'm going to share with you. And then that's it. That's the only thing I need to do, no matter if this namespace or cluster has hundreds or thousands of microservices. What will happen in the background is that we will add our micro agent to each one of the containers, And if containers, scale up, scale down, you add containers, you delete containers, we will be able to do it with Kubernetes. So it is used basically in many environments. It is being used to create secure tunnels and application level protection, as I mentioned before. The pros that you don't need to rewrite your application. It doesn't require specific privileges. So we are running in the same privileges as your workload, and we don't require any specific service account. So we're running in the same privileges and service account as your running environment. If you have end-to-end encryption, it's okay. We sit inside the container, so it doesn't really interrupt what we're doing. The only thing, and again, these are things and concerns that I'm hearing from customers, is that if we have an issue in the agent, it will break the application, and that's kind of true. It will not break the node. It might break a specific part of your application or the microservice that has this problem. But if you're deploying it in a correct way and you have health probes, then probably Kubernetes will be able to deal with it. And there are some CPU and latency concerns. Although I think that in most cases, the concern is coming from the Sidecar. We've ran some tests between the micro-agent approach and the Sidecar approach, and we've seen that while you have a relatively between 10% CPU and 10% latency when you're using a Sidecar, in our case, it's neglectable. This is why we chose not to be a Sidecar, and we chose to be a micro agent. So I'm going to try and summarize what I've said so far, and then I'm going to show you a demo that I think it will explain by itself what option or how you should consider when you're trying to consider your Kubernetes security solution. So if we look at the API, if we look at the privilege level, we see that the API, the best approach is to run with a workload agent, right? Because it doesn't require any specific privileges. If we look at the disruption, meaning that if the security solution will fail, your environment will continue to work, probably you should use the API. But again, it's limited. It doesn't give you all the capabilities that other solutions give you. If you look at end-to-end visibility in end-to-end encryption use cases, the only solution is to run as a workload agent. If we're looking at prevention, trying to prevent modern attack, in-memory, fileless malware, the best option is to run in a workload agent. If we're looking at the implementation or deployment effort, the easiest way is to use the API. Of course, it requires one single integration, and you start to enjoy the security values that it promises. If you look at malware prevention, it probably depends on what sort of malwares you're trying to prevent from. I'm going to show you in the next demo, in the last section of this presentation, then we will move to Q&A, the fileless malware attack that is run by Ijuri. Basically, Ijuri is a memory loader that runs in memory. Doesn't even land on the underlying host or on the disk. which creates a lot of challenges for existing security solutions. And I'm going to show you how this type of attacks can be prevented, and how it is related to the capabilities in each one of the attachment points. So we created a demo and recorded it, and I will try to explain what we're doing and what we should take out of this demo. So I'm going to play it. So now what you can see is that we are in a Google environment. We're running the Hipster shop with our protection, Claire, and Falco on the same cluster. This is the Hipster shop. It's a microservices demo created by Google, and we're using it in order to demonstrate this specific demo. You can see it is created out of many microservices communicating with each other, written in different programming languages. Now we are logging into our system, and we want to show you basically that in our environment, it is signed and attached. So you can see when it's signed and attached, you can see also the communication patterns. So you can see who talks with whom, and you can see that they are all protected. So this is this sign. Okay. One of the things that we will do in the demo is we will protect also the secrets. So this, in this specific case, we have one microservice who's using a secret called top secret. And we will show how we are protecting this top secret. So now we're using Claire. It's an agentless solution that basically scans the registry. And you've seen that Claire scanned the container that has the jury malware, and basically stated that it's safe. It passed the security controls and it's safe. And now we are updating the version of the content with this version that passed the vulnerability scanning. And we know that it contains the jury loader. But you can see that Quay.io and that is using Claire showed it as safe to use. So now in our case, since we're watching the memory of the container and we're running with it in runtime, we will be able to see immediately when the loader is loaded into memory, we will be able to show you that although the application is working and everything seems to be fine, we are going to show you that it is indeed compromised and you have a malware in your environment. So now the idea is here is that we created the malware, we crafted the malware in a way that it will start working after a few seconds, because we didn't want the malware to start when the solution is loading. And here you can see that we identified it, we marked it as compromised, and in a second you will see that in our insights we were able to say that it is compromised, and also you will see the second stage of the attack. But I'm not trying to spoil it yet, because we are running here in detection mode, not in prevention mode. So basically, we said it's compromised. We didn't throw the malware out. We just notified the user that someone is trying to attack the system, and now we will show the second stage of the attack, which is to take this top secret out of the environment. Okay, so this is the second stage. Oh, sorry. Before, this is the second stage of the attack, and in this second stage of the attack, we are using the backdoor in the Azure loader to basically communicate with us. We are acting as the attackers, and basically we landed on the front end container or the front end deployment, and now we're trying to see what we can take out of this environment. So we're running ls to understand what's running there. And now we're assuming, since it's a front end, it has the certificates or keys that it is using. But what we did is we encrypted them in a way that only the process, the front end process that is running, is able to decrypt them. So now, even although I'm the attacker, and I do cuts to this file, I get it totally encrypted because I don't have the privileges to run and decrypt this secret on myself, and that's why you can see this gibberish. Oh, sorry. I pressed on the wrong button. Okay. Sorry. Okay, so we see that the secret is encrypted. I'm sorry about me pressing on the wrong key. And now we will be able to track everything that the attacker did in our system, because we're seeing everything that is being run inside this environment. So if we go back to our dashboard and we look at the incidents, we are able to see that someone SH to our environment, and he was doing ls. And of course, we've seen that this action is unauthorized, and it was running inside the environment. Okay. Okay. The only thing that I have to add, what we've seen now, is that on the same environment, we ran also Falco, and Falco was unable to identify this specific attack. The reason is that Falco, although sits in the kernel level, is not able to see the process's memory. So in our case, since the malware is a fileless malware, a very sophisticated modern way that attackers are using more and more, the malware itself is running in the memory of the processes and is not lending or not writing any file to the file system. Host-based attachment points cannot really see these types of attacks. So the last thing, before we jump to the Q&A section, the last thing I want you to remember that it's not, it's not a religious question. It's not a question of right or wrong. It's not a question that you can make a mistake. You don't need to put too much focus into the attachment point. You need to think about the security value that you're looking. If you're looking to protect against every possible risk, if you're looking to protect your environment against fileless malware, then probably doing an agentless API-based solution is not the kind of solution that you're looking for. But if you're looking to run posture management, you're looking to scan your container registries, or you're looking to look into your YAML file deployments, then probably you don't need a kernel level deployment, a host-based or a workload-based attachment point. So it all depends on what you want from the security value rather than the attachment itself. And if you have any doubt, any concern, you're free to contact me, and I will try to do my best to help you with that. Thank you very much.
All right, great. Wow, so many demos. I love to watch the demos. We have plenty of time for question and answer, guys. So if you do have a question for Amir, please go ahead and use your question and answer tab or the chat tab, and we'll certainly move it over for you. Excuse me, we've gotten some great questions in so far. So let's go ahead and dive right on into those questions. The first one is from Andreas, who asks, what is the average latency introduced by your solution?
It's very, very small. It depends on the security capabilities that you require from the solution. For example, if you're using encryption, it adds CPU, but it doesn't add any latency, and it's neglectable. And if you want, we can talk later about the specific scenario. And try to answer that for your specific need.
All right, great. Next question here. What is the best option to protect Kubernetes secrets?
Wow, that's an interesting question. So Kubernetes secrets, basically, although it sounds like it's secrets and probably they are protected, they are not. I don't know if most of you know, but the fact is that they are stored in etcd as base 64 decoding, meaning that if you get access to a Kubernetes secret, you know every script kiddie can open it. And we have an option or a capability to protect against these type of challenges. By encrypting the secrets and allowing only the authorized workloads to access this specific secret. So in my opinion, the solution that we give is kind of the most security-wise the best option that you have in the market. I've seen a lot of customers who are using things like Conjure by CyberArk and Vault by HashiCorp. These are great solutions if you want to manage your secrets in a central location. However, you need to know that at the end of the day, they're not as secure as you think. And again, if you have any doubt about the security of these solutions, you can watch our blog section on the website where we share all these challenges around secrets and how we solve them.
Excellent. All right, guys, there's plenty of time for question and answer. So if you do have a question, go ahead and submit it, and we'll get to it hopefully by the end of today's webinar. Let's see, next question here for you. Let's see, what are the problems of using a sidecar?
So other than the fact that most of the people I talk to tell me that it's a nightmare to deploy and to manage, we have some customers that tried it and they complained about the extra cost. You know, at the end of the day, Sidecar is adding a container to each one of your deployment pods. And in some cases, like cloud, you pay per CPU and resources, and then, you know, it creates an extra cost on the environment. And again, it adds latency and you know, I haven't seen anyone that really used it and didn't complain. So
okay. Well, that should tell you everything right there then.
yeah.
All right, great. Next question here. David asks, do I need to change my application to integrate with the encrypted secret you provide?
No. This is a great question, because one of our benefits is that you don't need to change anything. We take your application as it is, and we just protect your environment without the need to do any change.
Great, excellent. All right, another question here for you. What would you consider should be the #1 priority for choosing which attachment to go with?
So again, I think that the first priority should be your risk. So when you define what you want to protect against, you need to see how you can get it with the lowest friction that is adequate to the risk you're trying to protect against. So, for example, in my last demo, I showed the fileless malware. You cannot protect a fileless malware, and you know, I dare you or anyone on the audience to show me. You cannot protect against fileless malware with an agentless approach, right? I hope it is clear for everyone. So if my risk is, and I want to protect against fileless malware, probably, you know, I will choose a different attachment point.
Mm-hmm.
And again, I think that the most relevant question here is, you need to challenge the vendor that is telling you my solution is agentless and I stop fileless malware. You need to ask, how do you do it? Mm-hmm. Show it to me. And you know, the proof is in the pudding, right? So you need to show it in order to prove that it is working as expected.
All right. Okay, it looks like we have one more question here. So if you've got a question for Amir, go ahead and use the chat box or the question and answer period. We still do have a couple extra minutes here, so there's plenty of time. So the next question here for you is, let's see, what are the pros and cons of using eBPF over an agent?
I think that eBPF is some sort of an agent. At the end of the day, you know, it's a host agent. And I think, you know, today eBPF it's a great buzz. You know, everyone talks about eBPF, but you know, at the end of the day, it's a technology. I mean, people are running, for example, CNIs, container network infrastructure solutions for years now. Some of them are using IP tables. Some of them are running over eBPF. You as a customer, do you see any difference? You see a difference in the networking or performance? If you see it, then you know, use the different attachment point. You know, use eBPF-based technology over IPsec. But if you don't see it, why do you care? Why do you care if it's eBPF or not? Mm-hmm. Just a buzzword, in my opinion.
Okay. All right. Well, we are about 9 minutes to the top of the hour. So I'm going to go ahead and leave the question and answer tab open to see if we get any last minute questions coming in from the audience. And while we are waiting, just a quick reminder to the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again for all those great demos, you will have the opportunity to do so. Following today's webinar, we are going to be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. All right, still no new questions in, so let's do this while we're waiting. Let's go ahead and do the question, or the drawing for the $425 Amazon gift cards. And let's see, our winners today are David. Yay, David S. The second winner is Oliver E. Congratulations, Oliver. Yay. Third winner is Andreas L. Congratulations, Andreas. Yay. And our final winner today is Maria G. Congratulations, Maria. Congratulations to everybody who did win. We'll be following up with you by email to get your Amazon gift card over to you. So please check your email. And if you don't see anything in your inbox, please check your spam folder. All right, it doesn't look like we're getting any more questions in from the audience. So I do want to thank everybody who did submit questions. There were some really great ones. If you do have any last minute questions, you can always throw it in here. If we don't get to it during the webinar, please note that the folks at ARMO are getting a copy of all of the questions that came in. So I'm sure that they'll be more than happy to follow up with you offline to get your question answered. Let's see, it looks like Okay. Yes, Hans is asking, is there a recording of this webinar? Yes, there is a recording. So as I said before, we will be sending out an email that contains the link to access the webinar on demand, so you can watch the recording on demand. I think that is pretty much about it. Amir, thank you so much for a great presentation.
Thank you.
I am all about the demos, so I just love watching them. Thank you again for such a great presentation and lots and lots of great information inside. So thank you. I also want to thank the audience for joining me today, especially here in North America where it's a little early on the day. So, but thank you again, and I hope everybody has a great day. And please, whatever you do, stay safe.
Bye.